Hi guys, today your introduction is going to be about functions. The learning standard that goes with it is 8FA1, which is understand that a function is a rule that assigns to each input exactly one output. The graph of a function is the set of ordered pairs consisting of an input and the corresponding output. A lot of words, but we're going to break it down. Our learning targets. I can analyze a nonlinear data set. I will know that an assumption of a constant rate of motion is not appropriate for all situations. So we're going to learn some vocabulary to get you prepared for class, and we're going to do a little bit of practice to help prepare you for what we're going to be doing in class. Our first vocabulary word is area. We've talked about this before. It's the size of a surface. Remember, all of these are have the same area because they all have 9 squares. Linear equation. A linear equation makes a straight line when you graph it. So a linear equation makes this straight line when you graph the point. Nonlinear equation does not make a straight line when you graph it. Solids. Solids are three-dimensional, 3D shapes. So if a shape has width, depth, and height, it is a solid. It is a 3D shape. Here are some examples of some solids: rectangular prism, sphere, cone, cube, pyramid, cylinder. These are all solids because they are 3D. They have 3 dimensions: 1, 2, 3. Volume. The volume is the amount of space an object occupies. So, with this shape, it's all of the space inside of it, all of the space inside this cone, all of the space inside the pyramid, inside the sphere. Like if you were to open a basketball, a sphere, all of the space inside it is the volume. So what are functions? Functions are any clearly described rule. It's a relationship or expression that has one or more variables, and it has inputs, and it has those outputs that are related to the inputs. Just like this. Our input is 0, our output is 4. Our input is 1, our output is 7. Our input is 2, our output is 10. Our input is 3, our output is 13. So think of it as a machine. You're going to input, you're going to put in that 0, and outside of the machine is going to come out a 4. You're going to put in a 1 into the machine, and out on the other side of the machine is going to come a 7. Okay, so let's look at this discussion to prepare you for what we're going to be doing in class. So let's read our situation here. Suppose a moving object travels 256 feet in 4 seconds. Assume that the object travels at a constant speed, that is, the motion of the object can be described by a linear equation. Remember, linear equations, when we graph them, make a straight line. Write a linear equation in 2 variables to represent the situation and use the equation to predict how far the object has moved at the 4 times shown. So here are our functions here. We have x, which is the number of seconds in motion. We have y, which is the distance traveled in feet. So we need to write a linear equation with 2 variables to represent the situation. So at 4 seconds, we know that it travels 256 feet. So let's write that. 256 feet is traveled in 4 seconds. So that means we use y on the top and x on the bottom. So remember, if we want to find the value of something, we need to get it by itself in the equation. So we don't know what y is. So we want to make sure y is by itself on one side. So in order to do that, we need to get the x on the other side. If we are dividing on this side, we need to multiply on this side. So if we multiply the x on this side, we have the equation 256 over 4x equals y. So to solve for this, we need to make sure that we do the equation that we can do. So 256 divided by 4, that is 64. We still have our x, so let's bring that down. 64x equals y. So we've been wanting to know what this y is. So we know that if we plug in x, we're going to get our y. So if we plug in this one, 64 times 1 equals y. So in 1 second, it's going to travel 64. So take a moment and pause your video to figure out the rest of these. Plug in x for our equation. So 64 is our constant rate. 64x equals y. This is our equation. This is our equation. So put in your x's to get what y equals over here. So go ahead and pause it and do those equations. So with a constant rate of 64, we know that in 2 seconds, it's going to be 128 feet, then 192 feet. So with this constant speed, our linear equation is right here. We can figure out what the distance traveled is using our linear equation. Remember, our linear equation is that equation that when we graph it, it makes a straight line. So let's take it a step further. Instead of the object, we know that the object is a stone. So if we know it's a stone and it's dropped at height of 256 feet, it takes exactly 4 seconds to hit the ground. So think about that. You have this stone up here, 256 feet. The stone you're dropping right here, and it's going to go down, go down, go down, and hit the ground in 4 seconds. That is what we know so far. How far does the stone drop in the first 3 seconds? What about the last 3 seconds? Can we assume constant speed in this situation? So this is something we're thinking about. Can we assume constant speed? Can we assume that when this rock is falling, that 256 feet is going the same rate all the way down? Can we use our linear equation that we had before to find out if where the stone was at each second? This is something I want you to think about as you're getting ready for class. Okay, so this is something I want you to consider while you're preparing for class. Let's watch this video.
We are here live on the roof. 3, 2, 1.
So if we were to slow down this video so you could see where the ball was as it was falling, this is the data that we would receive. At 1 second, it was at 16 feet. At 2 seconds, it was at 64 feet. At 3 seconds, it was at 144 feet. And at 4 seconds is when it hit the ground. So I want you to be thinking about our equation before, our constant speed linear equation. Y equals 64x. Will this work with dropping a ball down to the ground? So make sure that you are watching this video as many times as you need to prepare for class. Have a great day.